For this video, we are going to be discussing justifying solutions for equations. So similarly to how we justified our steps for the order of operations, we can justify the steps for solving equations. So if we remember back to the order of operations, we had something that looked like 3x plus 2 times x plus 1, and I wanted to, let's say plus 8, and I wanted to simplify this. Remember, we could say, well, that's 3x plus 2x plus 2 plus 8 because of the distributive property. And then I can say, well, that's 3x plus 2x plus 2 plus 8. And I changed my grouping, so that's the associative property. Three x plus 2x is 5x. 2 plus 8 is 10. We combined our like terms, and if we remember, combining like terms is substitution. And then these two can't be combined, so we're done. Our answer is 5x plus 10. But the key part is this over here, where we're justifying our work using properties. We're going to be doing this exact same thing for equations. And in order to do that, we need to have 4 properties that we haven't talked about before. And those 4 properties are what are known as the equality properties. So there are 4 equality properties, one for each operation: addition, subtraction, multiplication, and division. And each one of the properties says the exact same thing, that whatever you do to one side, you have to do to the other side. So for example, if we solve this equation, 3x plus 2 equals 8, all right, if I do, my first step is going to be subtract 2 from both sides. And the property that tells us we're subtracting 2 from both sides, that we have to do it on both sides, that's the subtraction property of equality. Then our next step is to divide both sides by 3. Well, what's telling us that we have to do it on both sides? That is the division property of equality. So we use these properties whenever we are doing some sort of operation. And the property is just the operation that you see. All right, so let's do some examples. Example 1 says, justify each step in the solution of the equation below. So I've got this equation here, 3 times 2x plus 1 plus 2x equals 59. And it's been solved for us, and we just need to go in and fill in the properties that justify each step. So let's take a look at, first off, this is just our given equation. There's no property. We just say that that is the given equation. We say given. All right, now let's take a look between our 2 steps here, between steps 1 and 2. What happened? Well, we see that we had 3 times 2x plus 1, and now I have 6x plus 3. Well, that's 3 times 2x and 3 times 1, so that is the distributive property. That looks like a B, but it's not. It's a D. So that is the distributive property. All right. Then I see what happens between these 2 steps. Well, in this I have 6 plus 3 plus 2x, and here I have 6x plus 2x plus 3. All I did is change the order. That is the commutative property. All right, moving on. 6 plus 2x plus 3, and then here I have 8 plus 8x plus 3. All I did is I combined my like terms to get 8x, and anytime we combine our like terms, we use substitution as our property. All right, so now we have 8x plus 3 equals 59, and now we want to solve this equation. So our first step is going to be take away 3 on both sides. All right, so that's what this step is saying. We've got 8x plus 3 minus 3, 59 minus 3. The operation that we see is that we are subtracting 3 on both sides. So this is the subtraction property. And we really should say the subtraction property of equality, but I don't really have space in here to write that, so I'm just going to write the subtraction property. All right, now, when we move down here, we're actually going to have two things that we need to write in this box. If we look over here, 3 minus 3, those cancel out because they add to 0. And anytime we cancel, that's going to be the inverse. So this is the additive inverse on this side. Because they canceled out, it is the inverse property. On the other side, I said 59 minus 3 is 56. That's just combining like terms, so that is just substitution. So there are really two different properties being used at that step, and we have to say both. All right, coming down, now what I'm doing is to get rid of this 8, I need to divide both sides by 8. My operation that I'm doing is division, so this is going to be the division property. And in my final step, I'm once again going to have two properties I have to put. My 8's cancel out. Anytime I cancel, that is an inverse. Only this time I'm dividing, so that makes this the multiplicative inverse. And I'm just going to write mult inverse. And on the other side, I did 56 divided by 8 is 7. That is just substitution. So as you can see from here, all I did is go through, look at each step here, and think about what property justifies the work. So let's take a look at one more example. Here's example number 2. And for this one, I would like you to pause the video now, try this problem, and then when you've got it done, start it back up and we will go through it. All right, so now that you've tried it, let's go through and justify each step in solving this equation. So our first step is always just our given equation. All right, there's no work to be done, so it's just the given equation. So I've got 4x minus 8 equals 7x plus 1. Now we know that when we're solving an equation like this, my first step is to get all of my variables on one side. So what we're doing is we're going to subtract 4x on both sides to get rid of this 4x. So what am I doing on both sides? I am subtracting 4x. So that makes this the subtraction property. All right, and now if I move down to our next step, this one's actually going to have two properties. On the left, 4x minus 4x is 0. They cancel out, so that is the inverse. It's the additive inverse, but I'm not going to write it. I'm just going to write inverse. On the other side, 7x minus 4x is 3x. That's just combining like terms, so we say substitution. All right. Now, my next step is going to be to get rid of this plus 1. And the way I do that is by subtracting 1 on both sides. So, once again, this is the subtraction property. All right, coming down here, negative 8 minus 1 is negative 9. That is just substitution. But on the other side, 1 minus 1 is 0. That is once again going to be the inverse. All right, so now we look at this, and our next step is going to be to get rid of this 3 by dividing by 3 on both sides. So that's going to be the division property. All right, and my last step is going to have two properties again. Negative 9 divided by 3 is negative, that shouldn't say negative 1, that should say negative 3. All right, so that is just substitution. But on the other side, 3 divided by 3 is 1. That is going to be the inverse again. And it's the multiplicative inverse, but I just don't want to write it. So it's just the inverse. So all we did is go through, take a look at each step, and decide which property justifies the work. Some of our steps had to have two properties. All right, so I'm going to leave you with your try it problem, which is to justify each step in the solution to this equation right here.